Good morning, good afternoon, everybody. Welcome to virtual demo medium voltage GIS circuit breaker testing with Sibano 500 with engineer Aditya Tinija. The question and answer will be with engineer Anas Abdel Qadir as well. Also, I'd like to welcome our team support, Marwa Alawi. She is the event coordinator for our MIA region. I would like to draw your attention to the microphone. As you can see it on the control panel, it is put on mute by the moderator to ensure a silent environment for the benefit of all our participants. If you are facing trouble hearing us, please ensure that you select your preferred handset or speaker for the audio section as shown in the screen here. Later on, there is a question and answer session. You can raise your hand and I will turn on your microphone to allow you to ask your question. Please note that this webinar will be recorded. We will stop the recording at the questions and answers. To ask a question through the sessions, please choose the question dedicated area as shown on the side. We will try to answer as many questions as we can during the webinar. However, in case a question is not answered during the webinar, please note that we will answer it in a follow-up email. We will also have some poll questions during the webinar that look like this. So you will have to do, all what you have to do is to click on the answer. Sometimes poll may appear in separate window. If you face difficulties in showing or answering poll questions during the webinar, we recommend that you change the browser you are using. Please make sure to download the presentations and other documents at the product and the product brochures as well from the hands out sessions, as you can see it on your right hand side. Please note that the content of this presentation are Omicron sole and executive properties. If you wish to record, copy, or otherwise distribute sites contents, please request prior written consent from us in Omicron. You should not post any webinars, video, accompanying files, contents, or link to them on any public platform such as LinkedIn, YouTube, Facebook, Twitter, or any other social medias. The recording will be sent to you in the follow-up emails. So this email will include the feedback form. We would appreciate your response to help us better serve your need in the future. Omicron also recently launched its broadcast series Energy Talk. A broadcast is a series of digital audio talks where expert users and industry peers share their views on various topics related to power system testing. The broadcast is also available in Spotify, Google Broadcast, and Deezer. More space will be available soon. We will share with you the link to the broadcast in the follow-up emails that you will receive after the webinar. Finally, we have and we are excited to announce the launch of the new LinkedIn Omicron MIA page. The page serves as a platform to share latest MIA power system update and contests. You can expect is like a technical papers, case studies, and event update and webinar in Arabic, English, French, and Turkish. We will share the link with you. We will share the link to our new page in the follow-up email. We kindly invite you to follow up to stay connected and updated with us. Before we get started, I would love to know what challenges you face and your working environment. So I will skip this actually. And before going to that, I would like to introduce myself again. My name is Ali Dawood. I will be the moderator for today's sessions. It is my pleasure to be with you today. This is my contact details if you would like to stay connected with me even after the webinar sessions finished. I've been working with Omicron since 2014. I have a great experience in power system. I have presented a couple of papers in different events like IEEE, SIGRE, and Smart Grid in Saudi. The main speaker of today is my colleague Aditya Taneja. She is a regional application specialist as well as an area sales manager. More than 10 years experience in the field of testing, of electrical testing, up to 765 kV voltage level. And here are the contact details of Aditya, so you can be in touch with him even after the webinar. About us in Omicron, we have now more than 900 employees from 45 different countries and 25 offices worldwide. In addition to our own offices, we have also our sales partner network in different countries, as well as a local service provider or a local service center who can support you in calibration and repair of your equipment. You can find the local contact from our website. Good to highlight this, we develop innovate top quality testing and monitoring solution for electrical power system that most of you are aware of. And the majority of development and production work takes place in our premises in Austria. And we have another facility located in Germany, in Berlin city, focusing more on partial discharge product and solutions. Once again, you didn't need to record any video today. We will share the recording with you after the webinar. Enjoy the webinar today, and you can visit our website to learn more about our solution, our product, and our contact details locally as well. Now, I would like to hand over to the main speaker, Aditya Taneja, to start the presentation. Aditya, floor is yours. You can start. Thank you.
Hello and welcome from my side as well. Today we are going to look at virtual demo of testing medium voltage GIS circuit breakers with Sibano 500. My name is Aditya Taneja and I'm the regional application specialist. In today's agenda, we are going to look at what medium voltage GIS is about. Then we will look into the testing product, Sibano 500. Then we'll look at various testing methods of medium voltage GIS with Sibano. Then we will look at practical examples and test results, and then I would be happy to answer your questions at the end. So medium voltage GISs are used in primary and secondary distribution with voltage up to 40.5 kV and currents going up to 4,000 ampere in some cases, but usually it is around 3.15 kiloamperes continuous rated currents. And these are mainly for indoor applications such as railway, oil and gas, petrochemicals. And in this panels, the important thing is that the primary part is sealed off and filled with SF6, which gives it very low maintenance and high um, operating parameters. The breaker technology used in these breakers is vacuum. So even though it is filled with SF6, the braking technology used inside is vacuum. They are having very high arc resistance because of SF6 filled um, um, interiors. And you can have different configurations like single bus bar, double bus bar, and then there are a few examples from different vendors, such as ABB has ZX series for the primary distribution and Safe Plus for the secondary distribution. Similarly, there are equivalent offerings from Siemens, Schneider, Eaton. So the idea of my presentation is not to give you details of these GIS, but to mainly look at the testing part of it. So in a typical medium voltage GIS, we will have following components. It will vary from different configurations and with different makes and manufacturers, but this will give you a good overview of what are the main components. So we have a low voltage component which has all the secondary wiring, and then we have a control panel which is giving the single line diagram and a possibility to operate the uh, um, the breaker and the disconnector, and also lock it out from the control panel itself. Then there is a cable end box, which where the cables are connected or outgoers are connected, and then you have CTs here, and also we can see breakers here, which is vacuum, and then we have this three position switch here, which is quite typical for this particular um, types of GISs. And then this whole compartment is filled with gas and sealed off, so you cannot open it during normal maintenance. And then there are the outer part, which is having a relief valve, and you can see them. Um, you can see them here. And the bus bars are also not accessible during the maintenance or during after the installation is completed. There is no way to access the main bus bar module, which is also gas filled. Now, a few things for us to note for these types of breakers. So if you see closely at um, the control panel of this GHA type of breaker from Schneider, the whole primary circuit is sealed off, as I mentioned earlier. So there is no way to access the main contacts physically. And as I said, there is a special three position disconnector switch here, which gives three positions. One is closed, second is open, and third is earthed. So this is quite a typical um, part of this breaker and has to be mounted on the site. So it has to be tested, and normally the testing is done via the auxiliary contact timings for uh, these disconnector switches. And yeah, as we see that access to the main contacts is not available. In a high voltage GIS, we have normally two grounding switches, one before the breaker, one after the breaker. But here there is nothing after the breaker, so there is no way to access it once the cables are connected, like during after the installation. But on the other hand, there is an important part which is also unique to these types of GISs. That is the voltage detection system. It is basically a bushing mounted capacitor which senses the voltage and gives us an output here. Normally it is used for uh, doing partial discharge measurement using this capacitor as a coupling capacitor. But we can also use this sensor for timing measurements in online condition. This makes a very quick timing measurement very easy on these particular breakers, and you can easily see if the breaker needs um, any further maintenance by doing a very quick timing measurements with these contacts in online condition. So we will talk about this. We will see a demo of this as well. So a little bit about the testing kit. Sibano 500 is a 3-in-1 test system for circuit breakers. It is having a timing meter and a travel meter, it, which is giving you 3 channels for main timing, 3 channels for auxiliary timing, and with a very high resolution. And then we have the um, high accuracy micro meter, which is the contact resistance meter, and this gives you possibility to test with currents up to 100 amperes DC and with a very high accuracy even in low resistance ranges. And the third thing which is integrated is a powerful AC-DC supply, which can supply to the breaker even when station DC is not available, such as in commissioning conditions, or you want to do a measurement independent of the station supply. And there is a powerful software which runs this test kit. So as you see, there is no screen on this. So it runs via your normal laptop, and the laptop provides possibility to have uh, database functionality so that you can store the results and use them later for comparisons, for reporting, and also it guides the user to perform the tests in a sequential manner. There is possibility to do automatic testing by grouping the tests, and also create a testing templates which can be reused by different users. And after you have completed the test, laptop-based software helps you in making automatic report, which is easy to store in a printed format. So this is the equipment, and this is the side panel of the equipment with all the connections. So a typical medium voltage application device would look something like this, with voltage input channels for routing the station DC through the kit in case you need to test with station DC and not with the internal power supply. Then there are 2 rows of measurement channels. These are multifunctional contacts. So as you can see, there is an A row and there is a B row. A row can be configured as voltage outputs, current outputs, voltage inputs, and binary inputs. Depending on what kind of measurement is done, um, suitable configuration is selected by the software. Similarly, for the B row, they can also be configured as voltage output, current output, and voltage inputs. Then there is a warning LED in case there is voltage exceeding 42 volts appearing on any of these contacts. It will give a uh, give a light signal, and this is mainly for the safety of the person using or connecting these cables. And then we see a communication card or a auxiliary interface which helps in connecting uh, to the laptop or uh, to a safety switch, like a 3-position deadman switch or something like that. And one thing which is different from other configurations of this equipment is it has a auxiliary module which has possibility to connect one external module for let's say travel measurement, and 3 additional binary inputs for auxiliary timing. So here you can do the main contact timing, and here you can do auxiliary contact timings all at same time. So this is how the hardware will look. And now let's look into the testing possibilities. So there are 3 types of measurement methods which I'm going to discuss. There can be more, but these are the most common ones. The first one is to do an offline test, timing test using the auxiliary switches. So in case you want to perform a test of this MVGIS in offline condition, then there is um, there is no way to access the primary conductors. In that case, you can uh, do the timing measurement of the auxiliary contacts, and through that you can calculate the timing of the main contacts. This is a very crude method, but sometimes it is used. There are a lot of flaws in this method because when you are measuring the auxiliary contact timing, it will not give you the exact main contact timing because there is always an offset. And then that calculation has to be known in that case. Or you can use this method of auxiliary contact timing to measure the auxiliary contacts of the 3-position switch, the disconnector switch. So this is one method. I'm not going to talk too much about this one in today's session, but we will talk about this method where we do all the standard tests on a circuit breaker using 2 adjacent GIS panels. So as we can, like if you see this example of 2 panels, so this is one MVGIS panel and this is the other one just next to it. You have the disconnector with 3 positions, closed, open, and earthed, and you have the breaker. So we can access, let's say, this breaker through this uh, point, which is like connected to a VT, and the other one from this VT. So we will see this method more in detail. And the third method, which is very unique to this types of medium voltage GIS, is online timing measurement using the voltage indication system we saw earlier. So we will look into this as well. So when we want to perform an offline test of a MVGIS, let's say this is the breaker under test, or this is the breaker which we want to know the functional parameters. Then we can access one side of the breaker uh, through the uh, through the VT connection here, and this will allow us to send the signals. And in order to receive it from the other end, we keep the disconnectors closed throughout the test, and we also keep the other breaker closed so that we can access this particular part of the breaker. This way we can send signals like current and measure the voltage to do timing measurements, to do contact resistance measurement, and we can also do motor current, minimum pickup, all the common tests which you would do for healthiness. You can do it on these particular in this method. So how a typical measurement setup will look like. We see here we have connected Sibano aero contacts on one side of the breaker and AN on the other side of the breaker. Now there will be three-phase connection. That's why there will be three different connections here, and at the neutral we will have to make a jumper and put it back to AN. And we can interchange AN with the A1, A2, A3. Does not make much difference for us from testing point of view. And we give the commands for operating the breaker, trip coil, close coil, and motor via B-row. So we connect B1 to trip, B2 to close, and B4 to motor, and BN is connected to back to the putting the signal back to the source. With this, we can perform all the measurements we talked about. And alternatively or optionally, we can connect to auxiliary contacts also along with the main contacts to perform the measurements. And we are going to look into this a little bit more in detail. My colleague Andreas has this breaker from ABB, Safe Plus, which he's going to test with using two adjacent panels together. This is an RMU.
I will start with the middle one, with the Safe Plus breaker. And I will start with opening up the test plan in Primary Test Manager. Therefore, I have the latest 470 version here. Open it up, select the right breaker here at the location, and create a new job, which has automatically created the required test plan for it. As you see, we have quite common tests: motor current, close, open, minimum pickup, contact resistance, and this specific VTM tests we have here. So let's start with the first one, which is the motor current test. Therefore, we have the supply for the motor switched off, and we will provide the right connection from the Sibano itself. So we're going to use the cable row B and connect those to the control terminal. The control terminal is here behind this lid, using the schematics, and then we can connect them. So BN goes to 52. We have close goes to 53. And the trip goes to 55. And then the motor, which is actually the supply also for the trip and close coil, goes to the 22 connection. So everything here is control is connected, and the next thing we connect are the main contacts, as we have here on the medium voltage package. We don't use the MC2s, which is not required on the medium voltage level. So we're going to use the arrow to connect the main contacts. So according to the wiring diagram, and because the access is limited on such a In such a setup, we're going to use the connections here on the bottom of the breaker. So one side, the red one, and the other side here, the black ones, and making the bridges. This is quite specific connection for a medium voltage GIS. The main feature of this type of breaker is that the primary path is encapsulated. It is sealed for lifetime, so there is no other way to access the main contacts of the breaker or any other contacts here. Therefore, you have to use those connection points here, and if they are already used and not possible, then the only way to connect the primary are these VTM features you see here. So we can use the VTM test for that. But to compare it with a regular timing test, we're going to connect it in this example like here. So everything is connected for the regular tests. And we want to start with the motor current test. Connected here. We see at the breaker is open, spring is discharged. So gonna press the start test button here. Now he's ready for execution. Now we execute the test. And you hear the motor, how is he's charging the spring. Now the spring is charged and we got the motor current, as we can see here. So next test is the close operation. Switch back the supply of the coils here. So let's do the close test again. Okay, ready for execution. Breaker is closed. We got here the test results open. Execute the test. And right afterwards, you hear the motor, how it's charging the spring. That's because I switched on the fuses before, so it does it automatically. So the next one in the list is our minimum pickup. So we're gonna run that test, increasing the voltage on the close coil until it trips. He's tripping it. Let's see the results. 15 volts. Let's do the other coil. And the result is telling us 15 volts as well. So those are the common tests we just did. The contact resistance in such a case with the main device, you're using one side the A row and on the other side the B row. So we have to rewire that, and the voltage sense is BN and B4. So we have here the A's. In that setup, I'm using such an adapter here, which makes it quite comfortable because we have Kelvin screws here. But of course, on the normal setup, you can use the regular Kelvin screws as well. So on the other side, we have the B's, B1, B2, B3. They go in here. And connecting the other side of the same phase, and then we're measuring the voltage drop, which is B4 and Bn. We have to close the breaker before we do the contact resistance test. So breaker is closed. We have the whole measuring path now closed. So let's start up measuring the phase A again. So having the 100 amps going through and measuring the voltage drop. So we have 240 microohms. Let's do the other phases. Execute phase B. And we got the results, 201 microohms. So the last one. So let's start contact resistance measurement of phase C. Executing. $230. So we went through all those standard tests for medium voltage breakers.
So we saw how these medium voltage GIS breakers can be tested in offline condition using two panels adjacent to each other. Now look at the other principle which is used in testing these breakers in online condition. So whenever we are taking a shutdown of these GISs, we can use these sensors, these voltage detection systems which are provided in the GIS for performing the test in online condition. So when we are taking a shutdown or putting it back in service. For doing this, we use the sensor which is mounted in the bushing. The sensors are connected to a protection circuit, and it also has an output which can be accessed from the outside. Normally there is a plug which is always connected to keep it grounded. In case we want to do a measurement, we remove this plug and connect our testing device across these contacts. So in our case, we will be using it to detect the voltage for doing the timing measurement. Otherwise, normally this contact is used for PD measurement as well. So in an online condition, we will have the system running, and we would like to connect our test kit in parallel to the running system. So we have the main circuit here, which is sealed off, we cannot reach that. Then we are having this voltage detection system which is outside, and this is the control cubicle which is getting the command from the relay, and we want to connect our test kit in parallel to that command so that we can detect when the voltage is given to the trip coil and close coil to start our measurement. And we would also like to get the indications, voltage indications here from here, so that we can know when the voltage profile changes to do our measurements. So for getting the command from the trip coil, we will connect B1 and Bn across the trip circuit. Then we will connect B2 and Bn across closed circuit. We can also measure the coil currents with a current clamp. And A1, A2, A3 goes to the three-phase output which is coming here. And similarly, AN is connected to the ground. And then we configure the test kit to record the coil currents and primary signal when the command is given. So now the equipment, once we begin the test, it will wait for the relay command to come to perform the measurement. This is what is done normally. I will show you some results, but also I would like to show like what my colleague has done. He has used our relay testing kit to energize the primary circuit with a small voltage to simulate the online condition, and he has operated uh, the breaker and try to do the measurement. So just note that when we see the video, in that we are using three-phase 300 volt signal for energizing. So voltages coming across these capacitors will be very less, and it is not the actual measurement which you see in an online condition. This is a simulated one at a very low voltage. So it is just indicating how the test runs, and I will show you how an actual test looks like later on. So now we look at the measurement with the VDS system.
Let's simulate some voltage on the mains. Therefore, I switch to a quick CMC card. I'm connected already. Let's use 300 volt outputs, the maximum, and switch it on. Now we have enough voltage to have the voltage indication devices on the medium voltage showing some errors there, and therefore we know it is in service, it is live, and we cannot connect the primary path anymore. So how to test this setup? We're gonna use the connection points here, and when we go back to the PTM and checking here the hardware configuration of the test here, you see that here the arrow goes to these connection points. So we are using the arrow cable And this is now connected to this specific voltage detection system. And you have here outputs. You need adapters for that. With this VTM test, we're providing also the adapters for that, so you can easily connect to them. And it is basically a capacitance which is measuring the voltage on the primaries. So we have very low signals. If the breaker is a 24 kV breaker, which means usually you have 10 volts or up to 30 volts coming out here. But because we have not so much voltage, it's enough to show how it looks like. But as soon as we connect, is kind of losing the power. But nevertheless, that is enough to show you the signals, how it works. So here we have the primaries connected. And when we go back to the PTM and the wiring diagram, we see that the trigger input here on the B1 and BN. So those are connected to this voltage detection system, to this Vega, and this one is connected to a trigger input, and we are using the same terminals as we did before. The same point where we connected the trip signal, we're gonna use to connect the trigger input. So I'm take the B-row cable here. Using for the trip command B1, checking the schematics. Trip signal is X152. So we have 52. And the neutral NBN goes to 50. 52, sorry, 55 is the trip signal. Yeah, I put it the right way. So this one goes to the common. Okay, so the trigger is connected. Check again. Common is on 52, and on 55 is the trip signal. So this trip signal here is waiting for a voltage trigger, and these buttons here can only be used if you do it mechanically. They don't need voltage, so I will use the relay to send the close and the open signal to it. So it is wired up, and we can now go back to the PTM. And we can start this test. So it is an in-service test waiting for a trigger signal. So when I start the test, he is waiting, and to send the trigger, I will use the relay here. Breaker is closed, sending the open command here, the trip command. Say OK. Then he trips the breaker. Test gets the trigger, and we see the results. Those are not so nice sine waves, as I mentioned. We using the CMC, not the real values, the real 24 kV. But we clearly see when the sine wave gets stopped and interrupted here. You can even overlay that with the other measurements you did before. So let's do the same for the closing. Here again, the main signals are the arrow, and here we have the B trigger. B1 is the trigger. We're doing the close. That means this time it goes to the close terminal. So we have to check where is the close signal coming. It is the 53. So we're going to use terminal 53 and connect that as well. Checking again, we have BN on 52 and B3 sends the close signal. So close is now connected to B1 in PTM. So we are set up. Let's send the start command. And again, Sibane is now waiting for the trigger. So I go back to my medium voltage GIS and telling him close. Okay. He closes, trigger is sent, the measurement is done and comes back. You got an idea where it might happen, but those are simulated signals to show you the principle. On the real medium voltage GIS, the sine waves, they look nicer. Okay, that was the demonstration about the medium voltage GIS.
So we saw this was a quick demonstration, a very easy setup for performing this measurement on a medium voltage GIS with using this voltage detection system. I'll show you some examples from a practical measurement, which I did in one of the Schneider breakers, where we used the same connection which I showed you earlier. And here you see I'm connecting to trip coil, close coil together, because I'm doing again a demo, and there was possibility to operate the breaker easily, open and close. But in live condition, you will not be able to do both the tests together. So you can just use one current clamp for trip once, and when you are closing, then you can just switch it to the closing circuit. Little bit of a close-up. So current clamps are connected to measure the coil currents, and the 3 voltage inputs are connected here, and you can see the voltage is live, so you can see the high voltage signal coming here. When I did the measurement, then you can see there was a very clear sine wave, and once the breaker opened, then the voltage start decaying in the capacitor. So it will take some time for the voltage to become zero. We are not expecting the voltages to become zero for doing our measurement. We can start doing our measurement when the coil current leaves the sinus profile, and we see 3-phase voltages independently here, and we can do 3-phase timing, and we can compare it with the online timing measurement or the recommended timing measurements as well for the online test. Now this one is the recommendation from the manufacturer, and this is written in German, sorry for that, but this is all converted into like the values are all comparing to this LS aus time. Aus is opening time, so all the 3 phases are within the limit. Then we see a closing time. Similarly, there was no voltage, and suddenly when the breaker closes, then a voltage signal appears. And again, we can do 3-phase timing measurements and compare it with the corresponding opening time measurement from the manufacturer. So this is quite easy as you see, and once these indicate any problem, then you can do further measurements to confirm what the problem is. So this is it. This is all about the demonstration, and a little bit about the information, like where to get such a device and how you can order it. So there is a medium voltage package already defined in our brochures and ordering details, which is attached. You can see this. You can see this ordering number as well. And this package is dedicated for medium voltage applications, for all the different type of applications, not only medium voltage GIS, but the medium voltage um, uh, VCBs, SF6 breakers, all of them. So this um, package contains the Sibano hardware with this auxiliary module. Then we have all the timing tests in service and off service. And then you have contact resistance measurement, motion analysis, coil and motor current analysis, minimum pickup test, under voltage release test, which is a newly released test in the latest PTM software, and an over current release test. Sorry. So these are, if you want to know about them, please send me a note and I will give you some information to read about these. But there are breakers which are having these under voltage release coils, and if you want to measure on what voltage, minimum voltage, those under voltage coils operate, you can perform that measurement also. This is quite niche test, and as you can see in this particular package, you can get all types of medium voltage breaker timing and contact resistance, motor current, all the tests which you would like to have. And also it has all the accessories, needless to say, included. And if you want to see exactly what cables and accessories are there and what are the other things, you can look into the ordering information catalog, which we have attached in this session. And yes, with that, I would like to thank you for your patience and your attention. Please visit our website for more information, or you can reach us for any technical support related queries through email or through our hotline support. Thank you very much.
Thank you very much, Aditya, and thanks also to Andreas who joined us for today sessions. It was very nice demonstration, highly appreciated. And now I hope Andreas and Aditya can stay with us for the question and answers. Also, would like to welcome our specialist Anas Abdel Qadir to the session also, who he would like to share his experience and knowledge in circuit breaker. Welcome, Anas.
Thank you, Ali. Thank you very much for welcoming
Appreciate
me.
it. Yeah,
Thank you.
Yeah, good.
Yeah.
So I would like you to utilize your experience also on circuit breaker, and thanks for joining us for today. Same things for Andreas, who was joining us from Asteria, and Aditya. I hope they can stay with us for the question and answers. Meanwhile, again, we open the floor now for questions and answers, gentlemen. So you can raise your hand or you can drop your questions in the question bar, so we can try and answer as much as we can. There are many questions actually. I hope we can answer some of them. The first one is, can we do both sided grounded measurement for high voltage GIS? high voltage GIS with Sibano 500. Maybe Anas, can share your experience in this regard, I guess.
Yes, Ale. Thank you for asking this question. So yes, it is an interesting application with Cibano and both side grounded GIS testing. It's more related to the safety, because whenever the system is live and the customers would like to, or the engineers would like to perform measurements while one bay is shut down and other bays are energized, there are more chances that the influences, the electromagnetic influences from the nearby base can come into the bay which is under shutdown. So for the safety purposes, we have to ground the earth switches on the both sides of the circuit breaker. So this is what usually a both-sided ground measurements represents. So the problem in those cases is with GIS, the resistance of the earth switch is very less. So if I'm injecting a current for very short time for such measurements, the current can take either the path of the ground or through the conductor. So a normal method of testing is not really applicable in those cases. So we need a different type of approach has to be done. So yes, the answer to the question is yes, we can perform the measurements, but we need an additional accessory called current sensing coil. So that has to be kept in the path of the ground. And then we perform the measurements, and we can measure the timing accurately with both sides grounded. Yeah. So yes, possible. And there are a lot of utilities is being used this methods. Because I saw also one example that's very interesting to share it here, that for a 380 kV systems, when they have opened the earth switch for the bay which is under shutdown, they found around 700 volts induced, so which is not really safe. So in those cases, yes, we recommend to do both side grounded, and they use this accessory, and our special algorithm can interpret the measurements done, and then can give you an automatic timing, and in what time the breaker opens and what time the breaker closes, and also other sequences like close open, open close open, all these sequences can be measured. So yes, it is possible.
Thank you very much, Anas, for sharing this. And actually, there is another question in the same regards about what other tests can be done with Sibano.
Yeah. So Sibano is a circuit breaker analyzer. So unlike there are many devices as a circuit breaker testing, they perform as the most important like the timing. But we always say Sibano is not like a timing kit, it's a circuit breaker analyzer. So there are many functionalities available within the device. So definitely timing is one of the tests that can be performed. And we already see that in this presentation for the medium voltage GIS switchgear. And other tests are like the motor current analysis, the coil current analysis that can be done automatically with the timing measurement, and under voltage over voltage test, because Sibano has its own integrated voltage source, so you don't need any additional voltage source to perform an under voltage checking for the breakers. So that is also possible. And then we can do minimum pickup test. So this is a test which identifies the quality of the trip coil, or at what time or what is the minimum voltage required to operate the trip coil, which is very important, because in all the cases a trip coil has to be ready. So even there is a slight changes in the station voltage, the trip coil has to be tripped. So we will check whether the minimum pickup, so we'll identify in what is the minimum requirement or minimum voltage required to operate the coil. And then we have the dynamic resistance measurement for high voltage system mostly, and especially the breakers with arcing contacts. We are performing the DRM measurements, and it also helps us to understand the performance of the arcing contact or aging of the arcing contact. And then the other test is the motion analysis. So motion analysis mainly done for identifying the mechanical performance of the circuit breaker itself. That is also performed with medium voltage and high voltage systems, but we need to access to the mechanical parts. to connect our transducers. And then if I explain, there are a lot of applications which is possible. The other, like the first trip test, which is also possible with Sibano. So the first trip test will help us to see the performance of the breaker itself when there is a under live system. So circuit breaker is operated for a long time, and then suddenly there is a fault happen and it trips under live condition, carrying the load.